Imagine looking up at the night sky and discovering that the moon is gone, not hidden behind clouds, not passing through an eclipse. It has simply vanished from existence. At first, the most surprising thing might be how little happens. There is no explosion in the sky, no worldwide earthquake, and no instant collapse of civilization. If the moon disappeared at this exact moment, you probably would not notice anything immediately. In fact, for about 1.3 seconds, Earth would continue to see the moon and feel its gravitational pull, because both light and changes in gravity travel at the speed of light. After that brief delay, the moon's light would vanish, and its gravitational influence would disappear with it. The night sky would suddenly become much darker. The full moon can be hundreds of thousands of times brighter than the faintest stars visible to the human eye. Without it, rural landscapes that once glowed under moonlight would become almost completely black. The Milky Way would be easier to see, and astronomers would enjoy darker skies, but for many animals, this sudden darkness would be deeply disruptive. Humans would also lose one of the most familiar objects in our sky. There would never again be a crescent moon, a full moon, or moonlight reflecting across the ocean. Solar eclipses would become impossible because there would be nothing large enough and close enough to block the sun. Lunar eclipses would disappear as well. The calendar would continue to show months, but the natural cycle that originally inspired them would no longer exist. The first major physical change would affect the tides. Many people assume that without the moon, ocean tides would disappear completely. That is not quite true. The sun also pulls on Earth's oceans and creates tides. However, the moon is currently the dominant influence because it is so much closer to us. If it vanished, tides would become much weaker, generally leaving only about 1/3 of their present tidal strength, although the exact effect would vary greatly depending on local geography. Coastlines would not suddenly be hit by one enormous global wave. Instead, tidal patterns would begin changing as the oceans adjusted to the loss of the moon's gravitational pull. In some locations, the transition could produce unusual currents, shifts in sea level, and complicated waves moving through ocean basins. But the long-term result would be simpler, much smaller tides driven mainly by the sun. Twice each day, vast amounts of water currently move into and out of coastal ecosystems. Salt marshes flood and drain. Nutrients are carried between the ocean and the shore. Sediments are rearranged and tidal pools are refreshed. Many organisms have evolved around this constant rhythm. Without strong lunar tides, some tidal flats would shrink dramatically or disappear. Coastal wetlands could begin changing, and animals that depend on them would lose feeding and breeding grounds. Mussels, crabs, worms, snails, fish, and shorebirds would all face new environmental pressures. Some species would adapt, while others could decline or become extinct. The effects would spread through food webs. A reduction in tidal mixing could change the distribution of oxygen and nutrients in coastal waters. Plankton populations might shift, affecting fish and the larger animals that eat them. Human communities that depend on fishing could also suffer. The moon influences life in less obvious ways, too. Many species use its light or its phases as a biological clock. Corals in some regions synchronize mass spawning events with the lunar cycle. Certain fish, turtles, insects, and marine worms time feeding, migration, reproduction, or hatching according to moonlight and tides. Some nocturnal predators hunt more efficiently under a bright moon. Other animals avoid open areas on moonlit nights because they are easier to see. Without the moon, the balance between predators and prey would change. The disappearance of moonlight would not destroy life on Earth, but it would create a global ecological experiment unlike anything in recorded history. Human infrastructure would mostly survive the immediate event. Satellites would continue orbiting Earth, and the International Space Station would not fall from the sky. The moon does influence their motion slightly, so orbital calculations would need to be updated, but this would be manageable. Earth's path around the sun would also change only a little. The Earth and Moon currently orbit a shared center of mass located inside Earth, roughly 4,700 kilometers from our planet's center. Together, they travel around the sun as a system. If the moon simply vanished without transferring any momentum to Earth, our planet would continue moving through space at almost the same speed. Its orbit might shift slightly, but Earth would not fly out of the solar system or fall into the sun. The more disturbing consequences would develop over much longer periods. Earth does not rotate perfectly upright. Its axis is tilted by about 23.4 degrees relative to its orbit around the sun. This tilt creates the seasons. When the northern hemisphere leans toward the sun, it experiences summer while the southern hemisphere experiences winter. 6 months later, the situation reverses. The moon helps stabilize this axial tilt. Its gravity acts like a steadying influence on a spinning top, limiting how dramatically Earth's orientation changes over time. Without the moon, the tilt would not instantly change, and the seasons would continue normally for many generations. But over millions of years, interactions with the other planets could make Earth's tilt considerably less stable. Computer models suggest that the exact result would be complicated. Earth would not necessarily begin tumbling randomly through space, but its axial tilt could experience larger variations than it does today. Depending on how the system evolved, the tilt might sometimes become much smaller or much greater. If Earth's axis approached 0 degrees, seasons would become weak. The equatorial regions would continue receiving intense sunlight, while polar regions could remain cold for extremely long periods. Ice sheets might expand, changing sea levels and global climate. If the tilt became much larger, seasonal differences could become extreme. A hemisphere pointed toward the sun during summer might experience months of intense heat, followed by a dark and bitter winter when it tilted away. Regions that are now temperate could face enormous seasonal swings. Ice could melt in one part of the year and expand again in another. These changes would happen slowly enough for some life to migrate or evolve, but they could still cause repeated ecological crises and mass extinctions. Agriculture and complex civilization would be particularly vulnerable because they depend on relatively predictable climates. The disappearance of the moon would also affect the length of Earth's day, although not in the way many people imagine. The moon's tides create friction as ocean water moves across the planet. This gradually slows Earth's rotation. At the same time, the moon gains orbital energy and moves away from Earth by about 3.8 centimeters each year. Hundreds of millions of years ago, Earth's days were shorter and the moon was closer. If the moon vanished, this powerful tidal breaking would become much weaker. The sun would still produce tides and continue slowing Earth slightly, but the process would be far less effective. Our current 24-hour day would not suddenly become shorter. Instead, its future lengthening would slow dramatically. Far in the future, Earth would rotate faster than it would have if the moon had remained. There is also a hidden geological consequence. Tides do not act only on the oceans. The moon's gravity slightly stretches and compresses Earth's solid crust, producing what are known as Earth tides. The ground beneath us can rise and fall by several tens of centimeters, although we normally do not notice it. Removing that influence would reduce this regular flexing. It probably would not cause a global eruption or trigger every fault at once. The moon's effect on earthquakes and volcanic activity is subtle compared with the enormous forces inside Earth. However, the sudden removal of lunar stress could potentially alter the timing of some earthquakes or eruptions that were already close to occurring. Scientists would be even more concerned about what the moon's disappearance meant rather than what it physically did. A natural object cannot simply vanish under known physics. If it happened, humanity would have evidence that our understanding of reality was profoundly incomplete, or that something unimaginably powerful had removed it. Every telescope would turn toward the empty region of space. Astronomers would search for debris, radiation, gravitational disturbances, or signs that the moon had somehow been moved rather than destroyed. Governments would demand answers. Financial markets would panic. Religions and conspiracy movements would respond instantly. Even if Earth remained physically safe, human society might not react calmly to the realization that an entire world had disappeared without warning. If the moon were destroyed instead of magically erased, the situation could be far more dangerous. Blowing it apart would not make its mass disappear. Most of the fragments would continue orbiting Earth. Over time, some could collide and form a ring, some might reassemble into smaller moons, and others could fall toward our planet. A large lunar fragment striking Earth would release catastrophic energy. Even pieces much smaller than the original moon could produce global fires, earthquakes, tsunamis, and changes to the atmosphere. A spectacular ring system might appear in the sky, but living beneath it could be extremely dangerous. So in this thought experiment, having the moon simply vanish is actually one of the least destructive possibilities. There would be one more painful loss. The moon is not only a source of tides and gravitational stability, it is also a record of the solar system's history. Because it has almost no atmosphere, wind, or liquid water, its surface preserves ancient craters and rocks that tell us about events billions of years ago. It may also become an important stepping stone for future exploration. Lunar ice could provide water, oxygen, and even rocket fuel. Bases on the moon could support science, astronomy, and missions deeper into the solar system. If the moon vanished, those opportunities would disappear with it. For most people alive at the moment of its disappearance, daily life might continue with strange normality. The sun would rise. Gravity at Earth's surface would feel essentially the same because the moon's direct pull on your body is tiny compared with Earth's. Cars would drive, planes would fly, and buildings would remain standing, but the oceans would lose much of their familiar rhythm. Coastal ecosystems would begin transforming. Countless animals would lose the celestial signal that guided their behavior. The nights would become darker, eclipses would pass into history, and humanity would live beneath an incomplete-looking sky. The greatest physical danger would not arrive tomorrow or next year. It would unfold across geological time as Earth lost an important stabilizing partner. The planet would survive, and life would probably survive too, but the long-term climate could become less predictable and potentially more extreme. The moon often looks like a silent decorative object hanging above us. In reality, it has shaped Earth for more than 4 billion years. It has moved our oceans, slowed our planet's rotation, stabilized its axis, guided living creatures, influenced human cultures, and illuminated the darkness long before the first artificial light was ever created. We might not need the moon to survive the next morning, but without it, Earth would slowly become a different planet, and every clear night would remind us of what had been lost.